Hello, we are finally at the end of Unit 5. This is section 5.8, and this should be a pretty brief section. We're going to talk about the inverse trig functions. So, let's first remember what an inverse function is. To be an inverse, a function has to be 1 to 1, or to have an inverse, a function must be 1 to 1. Now that means that no two x values, no two inputs will give me the same output, the same y value. A way of testing to see if a function is one-to-one is the horizontal line test. So let's briefly remember, to find the inverse of a function, I need to switch x and y and solve for y. Okay, that's how we find the inverse of a function. If I want to think about the inverse of the sine function, well, let's think about the graph of the sine function. This definitely does not pass the horizontal line test at all. Instead, I'm going to restrict the domain. If I look at just this section of the inverse sine, or of the sine function, from negative pi over 2 to positive pi over 2, then it is 1 to 1. It does pass the horizontal line test. So I can think about the inverse of this function. So if I restrict my domain from negative pi over 2 to positive pi over 2, then I will be able to think about the inverse sine. So if I take these x values and I evaluate the sine function, what is the sine of negative pi over 2? That's negative 1. Remember, sine is the y value. So I'm going to go ahead and fill the rest of these in for you, though you should definitely be able to find these values yourself. So on this restricted domain, the range of the sine function goes from negative 1 to positive 1. Now, if I want to talk about the inverse sine function, so we would normally write the inverse function f to the negative 1x, although it's not really an exponent, but that's how we write it. So we'll see it written like this, inverse sine, or you will also see it written as the arc sine of x. Now, we switch x and y, so that means my table of values literally just flips. Instead of putting in an angle and getting the side length ratios of my triangles, or the coordinates on the unit circle, I am putting in those side length ratios. I'm putting in my coordinate point on the unit circle, and I'm getting back an angle. So that's exactly why we care about inverse trig functions. There are a lot of situations, especially in the real world, maybe you're building something, or any kind of architecture, or it happens a lot in science too, where you know the side lengths of something, but you need to know the angle. And so we use the inverse trig functions to help us find that. So if I switch x and y, that also means my domain and range have flipped. So the domain of the inverse sine function is going to be the range of the restricted sine function, and vice versa. And then if I go ahead and graph this is not the most elegant graph, so do forgive me. But I have this table of values here. I'm just going to plot these points. This is pi over 2, negative pi over 2. I'm going to be very approximate here. That's it. The graph of the inverse sine function. If you use your calculator, this is the entire graph that it will give you. We've restricted the domain to between negative 1 and 1, so there are not arrows at the end of this graph. This is the entire graph. So, do I need you to know how to get this graph? Will I ever ask you to graph the inverse sine function? No. But I do want you to understand why we're restricting the domain of the sine function, where this is coming from, and how we get the inverse, because you will definitely need to find inverses of functions. Now, let's look at the inverse cosine. So we start with the same thing, right? The inverse cosine function looks something like that. Does not pass the horizontal line test. So what if I restrict the domain from 0 to pi? Then it does pass that test. So in fact, that's exactly what I'm going to do. And then I will evaluate these angle values. The range is again between -1 and 1. And then all of this flips for the inverse cosine. So again, we write it either like this, or you'll see it written as the arc cosine of x. So my table of values is flipped. That means my domain and range have flipped when compared to the domain and range of the restricted sine function. And now I can graph this. And again, this is incredibly approximate. Let's see here. I'm plotting these points. And if I had actually gone through those points, this is about what the function would look like. If you want a clearer picture, you can go ahead and use your calculator or Desmos. But that is the graph of the inverse cosine. So again, the domain and range have flipped. And I'm putting in the side length ratios. I'm putting in the coordinates from the unit circle, and I'm getting back the angle in radians, or we could also talk about the angle in degrees if we wanted. Forgive me. Sorry about that. So let's look at the inverse tangent function, because I've been sick for the last week, and I'm blaming all of you for it. Let's look at the inverse tangent finally. So inverse tangent is going to come, just like before, from the graph of tangent. Just like inverse sine came from the sine graph, inverse cosine came from the cosine graph. Now this is what tangent looks like. And tangent definitely doesn't pass the horizontal line test either. It does, however, pass the horizontal line test if I look at just one period. If I zoom in on this graph and just look at -pi/2 to +pi/2. So if I restrict my domain to just that section, and then look at the points in between here. So there's an asymptote there, an asymptote there. Then I see that my range, just in this section here, right, I have asymptotes at the end. So really my range is all real numbers. I'm going to hit every y value. And then my domain has been restricted to between -pi/2 and pi/2. So when I go to look at the inverse tangent, we write it like this, or we talk about arc tangent, then my domain and range have flipped, so now my domain is all real numbers. And then my range is between -pi/2 and +pi/2. And then my table of values has flipped. And I can graph this, or at least attempt to. This is not going to look very nice. So I had vertical asymptotes, but now when I switched x and y, I switched that. I now have horizontal asymptotes. If you want a better picture of this, then use your calculator. I implore you. Something like that. That is the graph of the inverse tangent function. So, you're asking yourself, well, that's great, but you told me, Mr. Boothman, that I don't need to know how to graph these functions, and that's exactly true. But you should now understand where these are coming from and why we had to restrict the domain for the inverse trig functions. And when we do that, that affects how I evaluate inverse trig functions, which is something you absolutely need to be able to do. So let's look at some examples, and you're going to work on 4, 5, and 7 on your own, but I'll go ahead and work on the others with you. Number 1, the inverse sine of the square root of 3 over 2. So I am putting in to the inverse sine function my side length ratio, and I want to know what is the angle that I would get out of that. So where is the sine equal to square root of 3 over 2? Give you a minute, think about it. Now, we can think about the unit circle. Sine is the y value, so that's going to be at pi over 3. It's also going to be at 2 pi over 3, but remember that the inverse sine function had its range restricted to between negative pi over 2 and positive pi over 2. So I can't get 2 pi over 3 as an output for the inverse sine function. So pi over 3 is my answer, and the only answer. If you were to use your calculator, that's also what it would give you. Number 2 is very similar. What is the arc sine, the inverse sine? Remember, this and this mean the same thing, of 1/2. So where does the sine function give me 1/2? Because now I'm going backwards. And again, it will happen in more than one place, but within our allowed range, the only place that happens is pi over 6. Where does the sine function equal 0? That's what the arc sine of 0 is asking. That is going to be at 0. You might say, well, that's also 0 at pi and 2 pi and 3 pi and 4 pi and so on. But remember, my range was restricted for the arc sine function to between negative pi over 2 and positive pi over 2. And we did that so that we could define this inverse. Otherwise, this wouldn't work. Because remember, if I want this to actually be a function, then I can only get one output. The definition of a function is that each input gives me one and only one output. So I have to only have one answer. So I can't look at 2 pi over 3. I can't look at, here would be 5 pi over 6. I can't look at any multiple of pi here. So go ahead and think about numbers 4 and 5 on your own. So if you're just looking at your unit circle, you will see two angles that work for this, or any of their coterminal angles. But then remember how we had to restrict the domain of the original function, which restricted the range of this inverse function. Now, just like for angles that are not nice angles from the unit circle, we can also take a look at using our calculator. So the inverse trig functions on your calculator are the second function for sine, cosine, and tangent buttons. So for number 6, if I want the arc tangent, the inverse tangent of negative 8.45, first I'm going to make sure I'm in the right mode. Negative 8.45 is radians, so make sure you're in radian mode. And then you're going to press second, the tangent function, that gives you the inverse tangent, and then plug in negative 8.45. Enter, and you will get negative 1.45. And again, I made sure I was in radian mode, so that means that my negative 1.45 is a radian measure. I'm getting back an angle. So I did just not clarify as much as I should have. Negative 8.45, that's my side length ratio. So that's not actually an angle. That's not why I need to be in radians. I'm in radians because I want my answer here in radians. My answer is an angle measure. If I was in degree mode, then I would have gotten this answer as a degree. Okay, so I will specify which one I would like. So go ahead and try those circled problems on your own. Make sure to really understand where these inverse functions are coming from and understand why we use them. There's so many places out in the world where I need to figure out the angle of something, and these functions make that possible. So thank you so much. We're finally at the end of this unit, so make sure to bring your questions to class and start getting ready for our unit exam. Thank you so much. Have a good one.